Everybody. This is a video to go through our Lesson 21 notes in a little bit more detail and make sure we have time to talk about every problem. I'm going to do this in a couple chunks so that you can use it as you're studying for your quiz. So I'm starting back at the beginning with looking at our first problem that we kind of broke down. This was the derivative graph. This was the f prime graph. And I suggested that even if we're looking at an f prime graph, we can still make an f prime number line. When we are indicating things on the f prime number line where the f prime graph values are positive versus where the f prime values on the graph are negative are the key elements. And at this point it looks like f prime values are positive up to -2. They then go negative for between -2 and 1. And then they're positive from 1 to 4 and then beyond 4. If we were looking at a y prime graph, the y prime or an f prime graph or a y prime, whatever, if you're looking at a first derivative graph, then the first derivative positive or negative values are aligned with whether the y values are positive or negative. Once we interpret the information from the graph correctly, it's just a matter of using the same skills looking at the number line. F is going to be increasing where f prime is positive, and that is going to be from -infinity to -2, from 1 to 4, and from 4 to infinity. You have to remember, and I said this repeatedly in class, that when we are looking at an f prime graph, we are not describing the f prime graph. So if you're looking and going, well, -infinity to -2 is not increasing over here, we're not describing where f prime is increasing. We're describing where f is increasing. And we don't have a visual of f to go by. But we do know the sign of the derivative of f. F prime is negative whenever f is decreasing, and so I know f is going to be decreasing from -2 to 1. And essentially this basic statement here, f prime is positive, f prime is negative, that's our justification. Relative maxes is mins. We have a relative max at x equals -2. F prime changing, oops, when I was added an e there, changing positive to negative. And then flip side, there's a relative minimum, or f has a relative minimum at x equals 1, f prime changing negative to positive. Now, that's all the f prime information that we get from the f prime graph. F double prime information we can get when we consider the slope of the f prime graph. So if I was going to make an f double prime number line, that corresponds to the slope on this f prime graph, I would have a negative slope and then a positive slope, and then a negative slope, and then a positive slope. So my slopes are negative, then negative to positive, changing at -1, changing at 2, changing at 4. Concave up is where f double prime is positive, and so that's going to be from -1 to 2, from 4 to infinity. Concave down, where f double prime is negative, -infinity to -1, union 2 to 4. The sign change in f double prime is the indicator of the point of inflection. So -1 and 2 and 4 are my inflection points. If you still haven't mastered what different information you get from f prime or f double prime, actually I'm going to write this on a different screen. Actually, I'm going to put this on a different screen altogether. That's if we still haven't gotten everything organized that we know about how to tell if f prime from f prime, what f is doing, that's where we need to go back to lesson 20. All of those details are in the lesson 20 notes. I actually think I have another handout that I'm going to post for you. The issue in lesson 21 is not so much what does the f prime number line tell you about f, but it's how do we generate an f prime number line from a graph of f prime. How do I generate an f double prime number line from a graph of f prime? The following problems have a mixture of skills. If you would like to do another problem that is the most similar to what we just did in number 1, number 9 is going to be the secret for that. Okay, I will post my key so you can check the key for problem number 9 and try it yourself. I will talk about part B because I did not talk about that part in class, but number 9 is a pretty straightforward, nothing extra tricky about number 9. It's very, very similar to number 1 in that you're identifying maximums, concavities, points of inflection of f from an f prime graph. Okay, I'm going to go ahead and jump back to a couple more problems from this note packet, and we'll talk about each one kind of a little bit at a time. Number 2 is the next one. Once again, this is an f prime graph. We're trying to figure out minimums and maximums of f from this f prime graph. And so I would create a number line. A and B are the two endpoints. We've got these 3 intermediate points that I believe I was goofy and made them my initials, because since they are the roots of f prime, or the places where f prime equals 0, they're critical values. They're the critical values we would generate algebraically from an f prime equation. From A to T, f prime is negative. From T to Q, f prime is positive. From Q to W, f prime is negative. From W to B, f prime is positive. This is f prime, that in the right order. Deciding whether f prime is negative or positive is me talking about f prime being values being below or above the x-axis. Once I get that number line, I can think about my behaviors. Decreasing to increasing makes there a minimum at t. Increasing to decreasing makes a max at q. And then decreasing and increasing again makes a min at w. So 2 mins and a max. That's answer C. We'll do one more problem in this video. This is in fact the graph of f, which we don't usually get. We want to figure out where f prime, or dy dx, is negative by looking at an f graph. Anywhere f is decreasing, f prime would be negative. So here's a little bit of a decrease. It's actually that one section is decreasing. So P is not in the decreasing section. Q is not technically in the decreasing section because it's at the very top of it. R and S definitely fit in the decreasing section. T is not. So if we're looking for, first of all, where dy dx is negative or f prime is negative, my options are either R or S. The second part, that's an f double prime equal to 0. That's a possible point of inflection. Change in concavity. So if my only two options to consider are R or S, looks like at R, we kind of go straight through R, versus at S, there's a little curve here, and then a slightly different curve there. So I believe of those two answers, S makes the most sense. Alright, I'm going to stop this video now, and then in the next video we'll do several more problems, still from lesson 21.